Hi, welcome back to Missing Chemistry. This is Chemical Equilibrium Rice/Ice Problems Lesson number 4. 0.05 mole of H2, 0.05 mole of Br2 are placed together in a 5-liter flask, heated to 700 Kelvin. What is the concentration of each substance at equilibrium at Kc equals 64 at 700 Kelvin? Alright, first thing we need to recognize is that we have a 5-liter flask. Okay, that's really important, because we have to take our molar concentrations and change them. So a molar is going to be 0.05 divided by 5, which is going to give me a brand new number of 0.01. And that's going to be both for the hydrogen and the bromine. Okay? I'm going to put that for the H2 and the Br2. It's going to be for both of those. So now let's go ahead and do our rice setup. We have H2, gas. We have Br2, which is also a gas. And we have 2HBr, which is also a gas. Our initial concentrations are going to be the hydrogen 0.01 m, the Br 0.01 m, and our initial concentration for our product is 0 because we haven't done anything yet. The change is going to be negative x because there's a 1 in front of the H2, negative x for Br, and there's a 2 in front of the HBr right here, so it's going to be 2x. All right. Positive 2x. It's going to be a positive change of 2x. So at equilibrium, you're going to have 0.01 minus x, 0.01 minus x, and then 2x right here. So far, so good. Okay. Now, let's go ahead and set up our problem. So we get, we have the Kc. So we're using Kc, which is products over reactants. So we have our Kc value. Kc value is 64, right? So let's just go do Kc equals P over R. That means products over reactants. So we get 64 equals, let's see here, our products, which is going to be 2x, right? But because you get that 2 there, it's going to be squared, so it's going to be 2x squared over 0.01 minus x times 0.01 minus x. You notice that that's also a square. So we can actually square root both sides. So what we're going to do is we take 64, take the square root of it, and square root 2x squared over 0.01 minus x squared. And that's going to give me, of course, 8 equals 2x over 0.01 minus x. All right, and when we put that together, we come back up here, do our math up here, and we get 0.08 minus 8x, because we're going to multiply that 8 to the 0.01 and x equals 8, right? Well, equals 2x. So I got 2x on that side there. So this is going to give me 0.08 equals 10x. Therefore, x is going to equal 0.008. So I'm going to plug in that for each one of these x's right here and get my values. So the H2 value is going to be equal to 0.01 minus 0.008. Our Br2 value is going to be 0.01 minus 0.008, and our 2h value is going to be this. So 2HBr is going to equal 2 times 0.008. So the value of the bottom one is going to be 0.016, right? Okay. The other one is going to be, of course, that's going to be 0.002, and that also is going to be 0.002. Well, that's it for that problem. All right, guys, so let's look at the next problem here. The next problem states that you have given Kc is 0.0057 at 298K into O4 is 3.5 molar, solve for the concentrations. Well, okay, so we're going to do our concentrations here. We got N2O4 gas, and then we have 2NO2 gas, okay? Our initial concentrations, of course, for this is going to be 3.5 because it tells us that it's 3.5. And our initial concentration for our product is 0 because nothing's been done. Okay, our change is going to be minus x, and this is going to be plus 2x. So equilibrium is going to be 3.5 minus x and 2x. Okay, so it's looking good so far. So let's do our Kc. Our Kc is like products and reactants. I'm just going to call it P over R to make it shorten. And so Kc equals, looks like 2x squared. Because of this 2, we have to square it, right? And so we put that over our reactant, which is going to be, of course, I believe it's 3.5 minus x. Okay, and our Kc value, we were given that, so that's this number right here. So this is going to give me 0.00057 equals 2x squared over 3.5 minus x. This is going to give me 4x squared equals 0.00057 times 3.5 minus x. Okay, and by the time everything shakes out, hang on for a second, let me look at my calculator here. By the time everything shakes out on this one, you're going to get x squared, you're going to get 4 x squared is going to equal approximately 0.002065. Since that number is so small, we're just going to throw that x out because it's not going to really affect anything, right? We divide by 4 and then take the square root of the x, and that's going to give me 0.023. Now we're going to take and put that into the value of x here and the value of x there. What about this x? I got rid of it. Why? Because this number is so small, it's so insignificant, it's not going to really matter. So sometimes you can do that. All right. So anyway, so we're going to go for our, let's see, our N2 O4 value. Right, let's go ahead and erase that, make that a little bit cleaner. So our N2 bracket N2 O4 is going to equal 3.5 minus 0.023, and our, of course, 2N2 value, 2NO2 value is going to equal 2 times 0.023. So our top value is going to give us, let's see here, I'm doing the math right now. It's going to give me 3.477. Polarity. And the bottom value is going to give me 0.046 molarity. And that's it for this lesson. You guys be snarly, and we'll see you back here at Musin Chemistry.